Good morning, everyone. This morning we have our next science sharing webinar, a very timely one. This morning, just to switch over to winter weather topic, and we're going to we have Joe Dellicarpini from WFO Boston and Mike Evans from WFO Albany. We're going to be talking about research that was originally inspired by Tomer Burg from OU. Who may or may not be able to be with this morning, but nonetheless, the topic is applying forecast track and intensity diagnostics to high impact Northeast winter storms. Is there a right of track bias? So with that, I will give you the floor, gentlemen. Thanks.
All right, thanks, Jordan. And so I'm going to start off, and then Mike is going to come in with a second part here. So this was a C-STAR project over, I guess, a few years. Anecdotally, Mike and the other focal points, Neil and Justin listed there, we kind of anecdotally said, whenever we get these big winter storms, it always seems like it's, going to be an offshore pass, and then it trends closer. So, by day 2 to day 3, we're dealing with a blockbuster storm in the Northeast when originally it looked like it was going to be out to sea. And we kind of wondering, was there really anything to that? Mike, got in touch with Tomer. We set up the C-STAR project, and of course, with our other collaborators, Andrea, Kristen, and Ryan listed there. Did a pretty nice study to kind of determine, is there really this kind of bias? And, does it happen all the time? Is it maybe in certain situations? So I'm going to present some of Tomer's original results, which was his master's thesis presentation back in 2019. And Mike's going to take a look kind of at some maybe a little more real world examples just to kind of reinforce the points. So the motivation originally was, taking a look, this was the January 2015 winter storm. And for those of you who remember, this was going to be a big hit along much of the Northeast corridor from New Jersey up into southern New England. And we had upwards of 3 feet of snow forecast one day out. And well, what happened, things shifted a little bit to the east. And, areas around New York City that were going to get 3 feet got 8 to 12, still pretty good, but not the 3 foot totals. Those are more confined here into New England. So, bottom line is we know snowfall forecasting is very difficult. So, and that obviously entails storm track. We always say, well, there's uncertainty in the track. And if it, tracks closer to the coast, these areas will be favored. If it's offshore, these areas will be favored. We do that time in and time out with snowfall forecasting. So, the rule of thumb, is often applied in operational forecasting, and this was, from some of the old timers over the years. Kind of noticed that, at a day 4 forecast for an East Coast winter storm, it's what can be well offshore, and then it'll trend west as we have decreasing lead time. So this is what's known as a right of track bias, meaning the observed track could be here from the Carolinas to maybe Cape Cod. But the original tracks were east of there, or right of track. So that's what we're talking about when we say a right of track bias. The model forecasts are to the right of what is observed. So this has been something that, has been kind of been known for years, especially when you have a bigger system, it tends to trend closer to the coast with decreasing lead time. A recent example, and Mike's going to get a little more into this, is the December 16th, 17th, 2020 storm. That was the 40-incher from Binghamton up into New Hampshire. Originally, and you can see, the track here is from Delaware, kind of hugged the coast and then passed over Nantucket. But originally, the storm was forecast to track more offshore, and this axis of heavy snow was actually further to the east across the Hudson Valley and into southern New England. I remember we had some expectations of getting the heaviest snow in our CWA, but turns out as we got closer to the event, the models trended further to the left and further to the left. So this was a pretty interesting right of track case. And again, Mike will get into this a little bit later. More recently now, Monday storm, and this is courtesy of Justin at Gray. Notice, this is all valid at 18Z Monday, looking at a bunch of different model runs. And you can see what started out offshore with some heavy snow across southern New England eventually trended very far to the west. And the track was eventually across upstate New York, and we ended up with a big rainstorm and wind here. So it's something that, happens. And, we want to take a look, is there a systematic bias in the GFS and its ensembles? And that's what our data set looked at, was the GFS and its ensembles, not all the different models. So getting into it, the project was looking at 3 questions. First being, does the westward trend rule of thumb hold merit? And that's what we're going to focus on today. He also looked at two other things: the distributions and trends in track and intensity errors. Were there, the intensity of the system affected? And then he looked at some of the synoptic scale patterns associated with these winter storms, and are they characterized by different ensemble spread and errors? So we're not going to get into that today. We're going to focus on this first one, talking about that westward trend rule of thumb. So what Tomer did was used a cyclone tracking algorithm specifically designed for Northeast US cyclones. And his identification used a hybrid of 925 millibar area average vorticity and height minimums linked within about 750 kilometers of one another. So this is kind of a diagram showing that here, looking at the 925 millibar low track and the vort max. The cyclone tracking uses a combination of motion extrapolation and the nearest neighbor, for some errors in location. And the cyclones were only retained if they last for greater than 24 hours. So we're looking at the bigger storms, we're not looking at the weak and more transient systems moving off the coast. So he developed a cyclone track database, and originally there were 601 cases between November 1st of 1985 and December 31st of 2015. So he retained cyclones in the data set that track within 750 kilometers of what we call the benchmark, 40 north and 70 west, for greater than 12 hours. They had a lifetime duration of 24 hours or longer, and they can be tracked within the CFSR using the tracking algorithm. So in this case, the 601 were decreased a little bit to 517 cases. So the results you're seeing are from these 517 cases that were retained. So here's all the tracks color-coded by their intensity. The star is, well, the star's a little off. There's actually, the benchmark is right here where the dot is. But you can see, obviously, a majority of the systems tracking just off the coast, some further inland, some further offshore, but really the sweet spot here was kind of clustered around that 40 north, 70 west benchmark that we often use for winter storm forecasting. So the question that we were addressing in this first part was, is there a systematic right of track bias? In other words, the model predictions being too far east of what was eventually observed. So in other words, models predicting an offshore pass, but in the end, it turned out to be kind of a direct hit somewhere in the Northeast. The hypothesis that Tomer came up with is there's really no systematic bias for all cyclones, maybe a slight right of track bias for the more intense systems that we see. And there is some truth to that. And so the method, he was assessing the evolution of a long versus a cross-track bias with forecast lead time. So we'll show some of the results here in histograms. I think this is kind of the easiest way to understand it. It's a little complex, but for simple people like me, I think it works out pretty well. So what we're looking at here in the histogram is we're looking at the number of cases in each of the bins. So we're looking at forecast position error. This is starting at 0 hour of lead time. So everything should be right in the center. Anything in the blue shading is a left bias in the track, and anything in the pink shading here is a right bias in the track. And you can see position error across track bias on the top in kilometers. And on the axis here, this is the along track bias here. So as we go through, and you'll see the different percentiles are mapped as well. So at 0 hours, obviously, we should be clustered right to the center, and that makes sense. A few outliers here, slightly to the right. As we go out, and let me go on, just to show, at 0 hours, again, left, this is a left bias and fast, a right of track bias and fast, and on the bottom, left of track bias and slow, and a right bias and slow on the right. So if our theory holds true that we have a right of track bias, we should see most of the clustering occurring somewhere on this side of the chart. And we're showing percentiles from 50th, 75th, and 95th percentile. So again, this is 0 hour lead time, everything kind of clustered near the middle. As we go out in time at 12 hours, you start to see a little bit of spread, still some good clustering right near the origin on both. You can see here a slight maybe tendency for a long track to be to the right at 12 hours. As we go out a little further, a little more spread, you're starting to see a little bit more of a left track bias actually at 24 hours, very slight there, most notably on the bar graph on the top. As we get up to 36 hours, still it's focused a little bit left and perhaps slow as far as the track bias, not so much on the right. So we're not seeing too much inside of 36 hours. As we go out in time, you'll notice it goes, 48 hours, and then we're at 72 hours. There's really, a lot of spread, but for the most part, they're centered pretty close to the origin. If anything, maybe a little bit on a left track bias as opposed to right. And then going out even further in time, here's 96 hours. Maybe a little left and fast, you could argue, just kind of finding the center of the 50th percentile. And at 120 hours, even a little bit of a left of track bias there. So not seeing a lot, on the right-hand side of the chart, which tells us there's really no systematic bias. And again, this is the GFS and its ensembles only. So in summary, does this leftward trend hold merit? There's really no clear signal for systematic right of track bias. On average, the cases exhibit a slow and left bias in the 24 to 72 hour forecast lead time. So I think anecdotally what a lot of us see when we see that, what we call right of track bias, the track trends to the left, say it's offshore of New England, maybe it tracks closer to Albany or Syracuse. And then there's almost a little correction back to the right as we get into that 24 to 72 hour period. It trends farther west and then we'll go a little bit nudge kind of back to the right, which could result in a slightly colder solution than one would be anticipating. So from there, I'm going to hand it over to Mike. He's going to show some kind of real life examples that I think will drive the points home a little bit more and kind of when we can apply that, what we consider a right of track bias. So Mike, I will hand it over to you and drive the bus for you.
Unmute. I'll never forget to unmute. It's been 2 years now. But anyway, yeah, so Joe, I'll have you drive. And we're just going to look at this whole idea of these right of track bias storms. Because even though, I think what Joe and what Tomer found there was clearly, if you look at all storms that occur in sort of the Western Atlantic, there doesn't seem to be this overall right of track bias that a lot of the forecasters insist on. But the question is, there's still certainly, if you look back on, historic storms over the years, we all remember these events that did occur where the models did kind of shift to the northwest. And they tend to be very high impact storms. So I wanted to look at those in a little bit more detail. And so, Joe, you could flip it. So yeah, definitely my motivation for this case was the December 16th to 17th, 2020 storm that went from Binghamton up into central New England. And I think that picture was taken near Binghamton. And again, this was one of these northwest trending or right of track kind of storms. So next slide. And you can see this is kind of drives the point home here. A few days before the storm, this is just the mean QPF and the GEFS. And it showed the heaviest precipitation well down over New Jersey, Delmarva. And again, the heaviest snowfall was well to the north of what the mean GEFS QPF was indicating. So next. And then as we got a little closer to the event, you can see the QPF is trending north. Now it looks like maybe the heaviest snow, eastern Pennsylvania, New York City, maybe southern New England, still south of what actually occurred. So next. And then finally, at 0Z17, I mean, this is when the snow had already started at Binghamton and the first flakes were starting to fly in Albany. And you can see at that point, the GEFS mean QPF did a pretty good job, but you could probably say too little, too late at that point. The storm was already underway. So next. And this is a graph that Joe already showed. Again, the idea here at 72 hours was that there's kind of a pretty even spread all around the graph, indicating that there's as many left of track storms as there appear to be these right of track storms. So it may be that, forecasters are we tend to remember these right of track or northwest trending storms because they tend to be the epic snowstorms for our forecast area. But the argument you could make is that, you can't just blindly apply a leftward movement to the model forecast. You'll be wrong as often as you'll be right, over the large scale. But still we have these overall, but still we have these cases that we all remember that were definitely right of track. And so I got in touch with Tomer. He's out in Oklahoma right now. And I had him kind of identify some big cases from his database that were right of track. So cases that are on the right side of this graph. And I wanted to look at those in a little more detail to see if we can see anything going on with those cases that ended up being right of track, that ended up being what, kind of what forecasters kind of remember happening. So yeah, we'll go to the next slide. And these are the cases that we were able to identify. So pick your favorite storm there over the last 10 years. There's some really big ones for the Northeast and Mid-Atlantic area. My personal favorite, I was in Binghamton for the March 14th, 2017 storm in the lower right there, also known as the Pi Day storm. And that was definitely another example where originally the heavy snow was forecast for New York City and ended up being in upstate New York. So, but there are several of these cases, and they become, they're major forecast challenges because the models, especially GFS, GEFS, were not as good as they could have been for these cases. So next slide. So we said, all right, let's take a look at just those cases then and see if there's something going on with these right of track storms that maybe isn't typical of all storms. So maybe we can identify these right of track storms in the future. So we looked at the NAR data for these cases, that subset of cases, looked at 500 millibar heights, and I think on the left there is 36 hours prior to when the heaviest snow was falling in the Northeast, and on the right is when the big snow band was right over somewhere in the Northeast. And you can see, nothing too surprising there. A trough moves from the Great Lakes toward the East Coast. You can kind of make the argument that it looks like the strongest flow in the center of vorticity at 36 hours on the left there is kind of over the deep south. Maybe, you put it over Arkansas, Louisiana, but then it definitely goes negative tilt as it moves up the East Coast. So next slide. And then these are the PMSL. Again, maybe not too surprising, but the one thing I would point out here is that at T minus 36, you've got a surface low actually in the mean over the Gulf Coast states, and then it tracks up toward Cape Cod. So these look like to me like Miller A type storms for the most part, storms that originate over the Gulf and move right up along the East Coast. And of course, for people that follow snowstorms in the Northeast, there's sort of two main types of storms that we get: the Miller A that come out of the Gulf and move up the East Coast, and the Miller Bs that come up the Ohio Valley and then redevelop on the East Coast. And I think there's some indication here these right of track storms may be a little bit more toward Miller A. And we'll look at the next couple slides, and that might kind of hit that home. Another thing I wanted to look at with the NAR was the convective precipitation. And you can see there's it's kind of dark looking there, but there's quite a bit of convective precipitation in the mean over the southeast US. And so the hypothesis there is that it's possible with all that convective precipitation that occurs with these deep south type storm tracks that you may get a little bit more ridge building on the East Coast in these kind of situations, which kind of steers the storms to the left. That would take quite an intensive verification and modeling study to really nail down, with high confidence. But it's a hypothesis that something like that may be going on, that convection in the southeast may be causing some ridge building, out at 36 hours that some of the, the GFS and maybe some of its ensemble members may not be picking up on as well as they could. So next slide. So another thing that we did is Tomer was able to give me a slide that showed when his algorithm first identified the cyclone that, for each of his cases. And on the left are his left of track storms. And you can see there's kind of a maximum actually over the sort of the northern Ohio Valley, lower Great Lakes. There's a secondary maximum along the East Coast, and then there is a weaker maximum in the deep south. So again, the left of track storms look a little bit more like Ohio Valley or storms that came in from the Midwest and then redeveloped. Whereas on the right there, the right of track storms, the storms that we're talking about here, there's definitely a pronounced maximum over the deep south where those storms were initially identified. Now, this isn't going to work every time because there were some storms that were, initially identified up over Ohio. But certainly there seems to be a difference between the right of track and left of track storms, in that the right of track storms are first being identified over the deep south. And then if we look at the actual storm tracks, left of track on the left, right of track on the right, it does look like there's a little bit more of a tendency for the right of track storms to be, the track to be tilted a little bit more south to north. Again, kind of implying that these are more your classic coastal storms that are moving up along the East Coast. So next slide. So again, this is what I just mentioned before, but if you divide storms, this I don't know when this Miller guy made this classification. This probably goes back to the 50s or 60s, but a Miller A, where the storms come out of the deep south, and a Miller B, where they come out of the Ohio Valley. It looks like the right of track, there's some tendency for these right of track storms to be more of these Miller A type events. So next, so of course we did have this really nice recent example that Joe touched on, and I just wanted to touch on that briefly. So you have, this is the GEFS mean forecast initialized way back on January 10th. So this was about 5 days for the storm. Again, on the left was 24 hours prior to the time when the storm was most widespread, and then on the right was kind of go time or storm time. So 5 days out, it looks like a complete miss for the Northeast, certainly for Buffalo, which ended up getting the most snow from this event. Just weak low off the Carolinas, and the mean moving well to the southeast of Cape Cod. And then next slide. On the 11th, you can see a pretty major change that occurred. More low pressure developing off the South Carolina coast, and then moving northeast to south of Cape Cod. This is where you might get excited now if you're in Boston or New York City. Maybe it looks like an I-95 type snowstorm. And then for the forecast initialized on the 12th, now you're starting to get disappointed if you're on I-95, because it looks like the low is actually continued to trend northwest and is now too far west for good snow on I-95. It looks more like a interior type of eastern snowstorm. And so then we go to the 13th on the next slide. Actually, a slight jog back to the right between the 12th and 13th. If you see that, it's small, but again, this was something that Joe kind of talked about. Was sometimes you get these big moves to the left, and then you can get slight corrections back to the right. So let's look at the 14th now. The 13th and 14th, I don't think there was much change. It looks like the storm is right on the New Jersey coast, at least in the mean. Of course, this is the GEFS, so there's spread here, but not much change from the 13th to 14th. And then we'll look at the 15th, and the 15th we jogged again back to the left. Now, even in Albany here and Binghamton, we're starting to worry about getting mixed precip, and it's looking really good for Buffalo. And I think that's kind of what ended up verifying. I think I got the 16th, and again, a storm ended up in central New York. And just really quickly, here's what the radar looked like the day or the morning of that storm as it turned up the East Coast. There was some convection in the southeast, and if people had been paying attention to what was going on down there, there was actually some severe convection in Florida, including an EF2 tornado that happened, I think it was near Fort Myers down there. So in many ways, this does look like kind of a case where this right of track, possibly could have been anticipated. But again, in this case, it looked like a lot of the movement, this northwest trending, occurred kind of in the early runs. And then once the storm got closer, to actually happening, the models were more consistent, although again, at the last minute, they did jog to the northwest once again. So I think, that's one, there's no silver bullet here. There's no easy way to say, okay, this storm is right of track, is developing in the Gulf, so it's going to be 200 miles further west than what the models show. There's still quite a bit of variety on how these things play out. And again, this one looked like it trended northwest kind of in its early runs and then maybe stabilized a little bit. Other times that trend continues unabated right up until storm time. So there's lots of things to learn about these storms yet. I think convection in the southeast may be playing a role. Also phasing, this was a case where there was a complex phasing situation going on between Northern Branch energy, which you can see with that snow up there in Minnesota on the radar, and the Southern Branch energy moving through the southeast. So complex evolution with this storm, phasing, convection, all the things that models sometimes struggle with were happening with this storm. So next slide, here's what actually verified at 12Z on the 17th. You can see the low ended up over State College. The heaviest snow was in the Buffalo area. Still some moderate snows in upstate New York, but I guess the I-95 area had more rain than anything else. And so next slide, this is just sort of a summary. So overall, again, this is kind of what Joe showed. If you look at every storm in Tomer's database, so, dozens and dozens of storms, there doesn't seem to be this leftward moving or right of track bias that some of the forecasters have noticed over the years. If you look at every storm, but there does seem to be this subset of right of track bias storms that do happen, and they have major impacts when they happen. And if we can anticipate when those can happen, that would be very valuable. Of course, the models change. And I do remember seeing recently Jeff Manikin talked about some of the improvements with the latest versions of the GFS and GEFS. And if memory serves, I think he still talked about some issues with the GEFS and GFS still possibly having a little bit of a progressive bias, which would mean an eastward bias for storms. So I think this idea that the GFS and GEFS, at least for a subset of storms, can be overly progressive. I think that's out there. I think that's not just a few rogue forecasters in the Northeast thinking that. I think this is something that the EMC model evaluation group people have noticed. And this is something that's been talked about in the private sector and elsewhere, I think, for many years. So there's something to this, but again, maybe down to trying to figure out which storms are really going to show this error and which storms are not, I think is a real challenge. Again, maybe Miller A storms, there may be more of a tendency for this bias to occur. And again, just a hypothesis, but southeast convection may be playing a role. And I think that's all I have.
All right, Mike, to you and Joe, thank you. A very interesting presentation. At this point, I'll open up for questions, and Jeff, go ahead.
Yeah, great presentation, guys. A couple of things I'll add. Mike, you're correct. I think when they went to the FE3 for the GFS and the GEFS, especially initially, there was a progressive bias, and that was universal, not just across the East Coast. And I think they're still seeing that, although it's improving, and of course they're still working on it. I think an interesting thing to dig into this most recent storm is that the atmospheric recon group out in the Eastern Pacific ran missions for 3 days on the 11th, 12th, and 13th. So what those extra observations may have done, relative to model sensitivities, and whether that helped pull the system west correctly and fairly dramatically, and it happened in all of the models, not just the GFS and the GEFS, but because I know those observations are assimilated in the EC, I believe the UK and the Navy. I'm not 100% sure about the Canadian. How much that played a role, at least in this particular case, and it kind of really ties to there's certain areas that are particularly sensitive to observations that they can then impact the model forecast many days, down into the forecast projection, and that's something that the modeling community is really actively looking at.
Yeah, just kind of getting back a little bit to what you mentioned. I seem to remember there's been talk for years. Again, I know Lance Bozart's been big on this. Is that the GFS tends to open up storms too quickly out of the Southwest, CONUS out into the Midwest, and so again, that's the idea that the GFS tends to be a more progressive model, sometimes too progressive. So I find it interesting that it seems to be, an issue, on the, sometimes on the East Coast, but like you said, kind of all over the place too.
Mike, it's kind of interesting. I think since the GFS was upgraded to the FE3, it's done a heck of a lot better, at least, anecdotally. And, look at the system here this weekend. For a few days, the Euro was showing a big hit for us on I-95. The GFS and the ensembles were well offshore, and it seems like the offshore track is going to verify. I mean, it's not done yet, but and this is one that's probably a Miller B, I would think. It's developing off the coast, redeveloping. Well, no, I guess it would be southeast, Mike, wouldn't it? Because it's down in the southeast, but it just seems like to me that the GFS and its ensembles have done a heck of a lot better since going to the FE3. I don't know if anyone else has noticed that.
Well, I think the December 16-17 storm didn't the FE3 was not the operational model at that time, but I think it was available to look at.
Yeah,
I think it did a lot better.
It did.
So I think there was hope. That was a good sign for it. And I think that does call to the point too, where if that storm this weekend just kind of moves harmlessly out to sea, people won't remember it, right? So
right.
You have a tendency to remember the ones that back in from the east, and you kind of forget about this one for the weekend if it just ends up not doing anything but be a fish storm. So that is definitely, I think there is an issue there with forecasters kind of remembering the ones that back to the west,
sure,
more readily than the other ones.
Yeah. Seth, you had a question?
Yeah, thanks so much, guys. This is really, really interesting. I enjoyed it immensely. So thanks for presenting it, and thanks to Tomer for this outstanding research. A little west of the Appalachians perspective, if you were to poll the forecasters in my office, and before this, if you would have polled me as a Sioux about if I thought there was a right of track bias, I would have said absolutely 100% yes. And it wouldn't even be up for debate. I mean, we see it, or we think we see it so frequently, and especially in the cool season where we start out on day 4, day 5 and dew points in the 40s, and maybe we're talking about mix or a cold rain, and then what we call probability creep of SPC probability starting out way down in Missouri and Southwest Kentucky, and they just start creeping northeastward with time as the cyclone drifts further west than the model guidance. So I think it's really interesting that there's this perception, and I love research that dispels myths. And so this kind of dispels a myth for me. But it's also interesting that in the points you guys have made, that maybe it's the big ones that are driving this. And even more perspective, I did a lot of my forecasting years prior to being a Sioux in La Crosse and Minneapolis, which is kind of the cold side of these intense cool season Great Lakes lows. And we would always watch snow bands that would originally start out on day 4, day 5 in Illinois, Chicago, into upper Michigan, and then watch those. And it kind of became a running joke is if the snow band is 200 miles southeast of you on day 5, you're going to be in a winter storm watch on day 2. And so I think this perspective is probably rampant across most of the Eastern United States in terms of what we feel is a right of track bias, but you can't argue with statistics. It's right there in the histograms you guys showed. I think this was fascinating. So
yeah, and Seth, I like that. Originally we just looked at the study and said, "Oh, gee, there is no bias." Okay, and could you leave it at that? That's kind of not like the rest. You got to go for the rest of the answer here. And I think what Mike did was great, splitting out the Miller A, Miller B, because from a meteorological perspective, that makes a heck of a lot of sense. You've got a system coming out of the Gulf, usually with a lot of convection. The models may not necessarily be capturing the strength of the downstream ridge, which tucks the system into the coast. Makes total sense. So I really like how we were able to split out the Miller A, Miller B. I think there's something to that, and that's probably where the right of track bias comes in. And thinking, messaging something. They in Boston, day 7, they go crazy. They want to start messaging. What's going to happen? And you guys know, you see that on social media and everything else. But even the partners, now in COVID, they want, because of staffing and low staffing, they want heads up at days 5, 6, and 7 to plan. So probabilistically, how do you handle that? Well, if you've got a system coming out of the Gulf, you could say, you know what, this thing could trend a little bit more west. I can message at least a low probability that there's going to be some impact. Kind of what we did with this one coming up for the weekend. Originally, the EC showing bonkers, and our rule of thumb is if it's looking perfect at day 4, it ain't going to happen. You don't want it to look too perfect too soon. But you can at least message, knowing that in the back of your mind, it's a Miller A. There's a lot of convection, a lot of severe weather in the south. That's going to, cause some downstream impacts. You can use that to your advantage to message things probabilistically, saying, we think it's offshore, but keep in mind, there is a low chance it could come closer and bring some impacts. And then you can gradually ramp up that message as you get closer and the models, come into a little more agreement. That's how I kind of look at it.
Yeah, and I think the phasing too, that between the northern and southern branch is another thing that, models are going to struggle at, especially out on days like 3 to 5. So the big ones, you often get some phasing, but, maybe the GEFS doesn't always phase things that end up phasing. So I think convection may be playing a role, phasing may be playing a role. I think, some bright, energetic person with time on their hands could do a study and maybe look at that a little bit more. But I do think those would be two issues to look at for these.
Yeah, and obviously, Mike, it's a very complex interaction. It's not just one thing or two things or three things, as we all know. It's an intermingling of so many different things. Seth, did you have something else?
Well, I was just going to say thumbs up to what Mike just said about phasing. It seems like, at least in the west of the Appalachians types of storms, these big Great Lakes lows, it's almost always a phasing issue to some degree. And so I think that's really a big part of it out here. And I just wanted to comment, Joe, you talked about the new FV3 GFS. I 100% agree. It seems 10 times better in the last year than it ever used to be.
Yeah, I mean, even during the tropical season, it did pretty darn good. Yeah, so I'm impressed, and hopefully, this is a trend that we see continue.
I used to tell our forecasters that the ECMWF would show today what the GFS will show tomorrow, and I'm not seeing that anymore. And right. I think it's really been improved significantly.
I agree. Anybody else?
So So I just wanted to add some comments from my end. First of all, Tomer sent an email expressing his apologies for not being here. However, if anyone does have questions directly for Tomer based on what was presented today, feel free to pass it forward to myself or any of the presenters, and we can get that forward and get those questions answered and responded to. Another comment I was going to make about this overall. I'll let you go first, Rob. Go ahead.
I was just going to ask, has this information been shared with WPC as well? Because I kind of think that them having this information would potentially help these collaboration forecast calls where, we don't have to all maybe, be saying the exact same thing on a collaboration call. We can kind of talk about this in advance. And then I presume also that it's being shared with, the ENC group and the MEG group to kind of see, are there things that we potentially can do to kind of help mitigate these strategies or mitigate this issue moving forward? I mean, I agree with everything that's been said before. We've all kind of had this right of track bias in our head, and it's nice to see that there really isn't systematically, but the big events are the ones that most people remember, and the big events are the ones that drive the bus. And so, seeing that there is a little bit of a shift in the Miller A situation for a big event certainly seems like there's room for us to kind of start hedging that messaging a little bit earlier in advance.
Yeah, I guess my response to that, I know that Joe and I and like Justin up in Gray, Neil down here in Albany, and we've been going back and forth on this issue ever since Tomer's project, and we have incorporated Jeff Manikin into those emails, and he's definitely contributed, his insights and opinions. So, we presented this at NRAW and here, but I know the people at EMC, Jeff Manikin in particular, is aware of this and aware of what we've been looking at and doing. So there should be, I think there should be some knowledge about this down that way.
Yeah, and we can certainly share this with WPC as well. I can follow up with them and either we can do maybe a brief webinar for them, Mike, or just share our findings with them. I think that would be sufficient.
Sure, either one would be fine. We could do this, what we just did, or we could at least ship them the PowerPoint or whatever they want.
Yeah, because I think that might actually be the most beneficial thing for us is that, if we're able to kind of help explain the messaging, to some of the people who are trying to collaborate and get all of us to collaborate, it might potentially help them, start from a more common place and not have to hear, a bunch of different ones to say, well, I think we need to maybe shift a little bit to the west, a little bit. It's just a thought, just an idea. But I mean, I know that the previous event we just had where we had the winter storms out in Buffalo, those guys wanted to issue the winter storm watches for good reason, well in advance. And, you know, a lot of us were kind of thinking, hey, it's probably going to take a Western track. And we were kind of asking for that, but most of the guidance wasn't quite there yet. And so I'm wondering if we were all kind of on a little bit more same page for a Miller A. There can be a, you know, right of track bias that might shift things a little bit to the west. That might have potentially helped us a little bit getting further lead time. I mean, not that our lead time was bad by any means. You know, everybody did quite well with this.
Yeah, no, that's a great suggestion, Rob. Thanks. And yeah, at least it gets everyone on the same page. So we can, and this, as Eric noted, this was recorded, so we could even share the recording with them and make it easy.
Yeah, Joe, and I think Tomer presented either last year or the year before at one of the winter weather experiment webinars. So
Oh, great.
I'm pretty sure they've seen his work, and you know, and Tomer he's out there. He's not shy about sharing what he's
absolutely
what he's doing. So
thanks.
I was also going to acknowledge Tom's comment in the chat. That's something I can absolutely pass back to Tomer in his considerations, although he also is going through his qualifier exam, so we'll see how much time he actually has to investigate that additional question, but I'll pass it to him nonetheless. One comment I was going to add, this kind of connects to the Meg call coming up after this I mentioned in my email out, is that this is a great opportunity to also consider the utility of the MBM 4.0 versus 4.1 winter weather products to see their efficacy compared to whether we're looking at ensemble approach or deterministic models moving forward. And this is a great opportunity for this type of situation to see days out how the systems are handling it from an anecdotal perspective, especially since, of course, the 4.1 is just what it is. It's experimental. So this is a perfect time to provide that feedback so we see how these events are performing. And going back to Seth's comments, which I loved how he kicked it off, that it's important, and this is a great presentation, to delineate the hard line between historical bias and statistical context. And this did a great job of that, and really will help bring this forward, along with other research, including but not limited to the factors like blocking in these situations too, and how blocking loads are being captured as well, which I know is a big issue with the progressive nature of these systems. Those are the comments I wanted to add. Also, Eric, thank you for sharing Tomer's plug to his webpage with the library resources. And yes, Jack saying that the 2020 presentation is in his inbox. So confirmed, it was presented. So that's great. Thank you for sharing that, Jack, as well. With that, I will ask if there are any other questions from anyone about this topic or anything related. Okay, I'm hearing silence. So I'm gonna say, Joe and Mike, thank you so much for this presentation, and really what was a great conversation. Of course, as Eric noted in the chat, this presentation has been recorded and will be uploaded to the Eastern Region Google Science Sharing site, hopefully later today, tomorrow, depending upon processing time. And other than that, thank you for all of your time. We'll give some time back. And again, Joe, Mike, thank you so much. And thanks to Tomer for this great research as well.
Yeah, I have to thank Tomer. I mean, he did the heavy lifting. He made it, we look good because of his work. So he did a fantastic job.
So other than that, thank you so much, everyone. And stay warm. And I guess we'll keep our fingers crossed for more snowstorms to test these thoughts. Take care, everyone.